everybody. Let's try this problem. So we have a beam. Let's solve for the reactions at the supports. So I'm going to just call these A and B. So pin at A, I'll decompose, and a roller at B. And there's the couple right over here. Okay, so let's solve for those reactions. Okay, so in the x direction, AX, y direction, the some torque about wherever, point A. Okay, so let's see, this is 6 meters times by, and then this couple is actually going in the negative z direction, so that's minus. Okay, so by has got to be 600, and then ay is opposite of that, minus 600, ax is 0. Okay, so we got the reactions, so it looks like, okay, ay was negative, so that's this way, 600, by was this way, okay, and then there's the couple right there. Alright, so let's figure out the shear force and bending moment, but using the calculus relationship. So again, dv dx equals negative w. Okay, so what is the loading curve from here to here? There is none. This is 0, right? Which means it's constant. So when we're on this side of the beam, there's definitely nothing happening. There's no shear. But then suddenly we encounter this 600 Newton reaction going down. And is that positive or negative? Right, so we're cutting along the beam. If we cut it over here, this way is axial force, this way is shear, this way is bending moment. So this is actually in the negative direction. So this would be negative 600, suddenly. But then from here to here, constant. So it's constant. From here to here, still there's no loading curve over here, so it's still constant. So it's constant all the way over to this side. And then suddenly, here we encounter this positive 600 Newton reaction, which is positive like this. And then over here, there's nothing going on. Okay, so this is the shear as a function of x. And that was just using this one formula. Right, just using this. We got this. Okay, how about bending moment? So for the bending moment, right, so what's happening? Over here, nothing. There's nothing going on. But then from here to here, we have this shear of negative 600. And the relationship is like this. dm dx equals v, which in this example it was negative 600. Okay, this is between 0 and 2 meters. Okay, so then how do you solve for bending moment? Move dx over here. Integrate both sides from 0 to some x between 0 and 2. M at 0 to some m between 0 and 2. So it is minus 600 x from 0 to x. Okay, so what does that look like? It's just a slope of negative 600. Kind of like this. And then at x equal to 2, it should be down at negative 1200. Okay. But then at x equal to 2, suddenly there's this happening. And then is that positive or negative? Again, right? Axial force, shear, bending moment. So this is actually in the positive direction. So suddenly we encounter this positive 3600 like this. So I didn't leave enough space, so not to scale. So this goes up 3600. From here to here is 3600. So that means it's got to go up to positive 2400. Okay, and then from 2, between x equal to 2 and x equal to 6, so from here to here, once again we have this shear. So let me jot that down. Between 2 and 6, dm dx equals v, and that shear is still negative 600. Okay, so how do you solve for m? Move dx over here, integrate both sides, but let's be careful. We're integrating from x equal 2 to some x between 2 and 6. M at x equal to 2 to some other m of x between 2 and 6. Okay, so m minus m at 2, which we just said it was at minus 1200 over here, and then it jumped up to positive 2400. So this is positive 2400. Okay, and then minus 600x from 2 to x. So let's evaluate that. There. Okay, so between 2 and 6, the bending moment is 2400 minus this. Okay, you can simplify, but I'll just leave it like that for now. At x equal to 2, right, this is 0, it's 2400, which is right here. And then as x increases, right, look, the slope is negative 600. And then what happens at x equal to 6? And that's going to be 4, so 2400 minus 2400 is 0. Right, so the slope is like this, and then reaches 0 right there. Okay? So hope that's helpful. So keep on practicing and just be careful about those limits of integration over here. Okay, so see you on the next video.